Okay, guys, so chapter 1 in Algebra 2 is a relatively quick and easy chapter. It's going over, today we're going over patterns and descriptions and, nothing too crazy by any means. So as you look at example 1, it asks us to look at the figure. It asks what is the pattern, and then what is the next figure in the pattern. So as you look at those shapes on figure A, any thoughts on those? Okay, it gets another side. They keep on getting another side. Is that essentially what you guys see happening? So what's that mean about my next shape or my next figure? Okay, it's going to have 6 sides, and if you recall the name, it's a hexagon, right? Does it matter how I draw that hexagon? Okay. 6 sides. Now, and that's, debatable question. If you notice the others, as you go along and follow the others there, is this just some random triangle? It has all 3 sides are the same, and all 3 angles are the same, yes? What about our 4-sided object? All sides same, all angles the same? And our 5-sided object? The same. So what should probably happen with our 6-sided object? It should attempt to be the same, okay? I don't know if you, well, first of all, what's the name for it? Just a general name for shapes? Polygons? Yes? That's a good word to remember there. So these are all polygons, yes? Now, here's the tougher part. What's the name for it when all sides and all angles are the same in a polygon? Well, equilateral specifically goes to a triangle. In any polygon, when all the sides and all the angles are the same. How about regular? I don't know. Maybe that's not one you guys learned very much, or no, just regular. You guys are looking for something fancy, and I just want plain. Okay, so it's the official mathematical terminology that if a polygon, all the sides and all the angles are the same, it's called a regular polygon. As opposed to if I draw some triangle where all 3 sides are different, it's still a polygon, but it's not what we call a regular polygon. So, okay, so first of all, let's draw our 6-sided object. Do the best attempt you can at a regular polygon. You will learn real quick. I am a math teacher. I am not an art teacher. That is my attempt at a regular hexagon. Is it perfect?
Yes.
In Ezra's eyes, it's perfect. I'll take it. So, it's as perfect as it's getting here. Does it get the idea across? And that's what I want from you guys, okay? I'm not going to grade, if I can't draw something like that perfect, I'm not going to grade you guys on drawing something like that perfect, but you can tell I made the attempt, right? That's what I'm looking for. Okay, so now the next thing was what is the we drew the next figure, but we also want to put it in words. And so to put this in words, remember we were talking about that these are all regular polygons, and what's happening each time, we are always adding another side, right? So something along that lines is what you'll want to write down. Looks like on mine I have regular polygons with the number of sides increasing by 1 each time. I'm going to write it over here off to the right. Regular polygons with number of sides increasing by 1 each time. Your wording does not have to be precise like that, but it needs to get the same gist across. Okay. What about B? Okay. Adding a block to each side. What are we, block, square? What are we adding that block or square to? What do we start off with at first? In other words, what's in the center here? Another square, right? So this first one is a square with a square on each side, right? What happens the next time? This time it's a square with two squares on each side. Then you continue to add another square each time, right? So what do I have to draw? A lot of squares, is that what I heard? Okay, so you've got your center square and then 4 out each time, right? There's my center square. And here is the reason I don't grade on artistic value. I'm not crazy about that one at all, but does it get the point across? That's what I'm judging. Okay, put it in words. We started with a center square, and we were adding a square onto each side, increasing 1 each time, something along those lines. I'm trying to think what I wrote here. A center square with a square added to each side, increasing 1 each time. So I'm writing a center square with a square added to each side and increasing by 1 each time. Probably could have been a way to cut that down. I feel like that got kind of wordy, but the other idea is when you're describing this, describe it as if whoever's trying to draw this doesn't have that first picture. They don't have any picture. They're just trying to go based on your description. Okay. Everyone got what they need there or getting it? Okay, problem 2 when you're ready. How many lines are in the 20th figure? And notice it specifically says use a table. So we'll talk about the table here in a moment. So let's start with, what do you guys see right now? Okay, it's adding another square each time. Okay. Now what's the question asking me though? How many lines? Okay. So right here, this first single square, I'm going to call this is figure number 1, yes? The next figure is figure number 2. And then we have figure number 3. Could we keep drawing all the figures up to the 20th figure to get our answer? Yeah, you could. Is that what we want to do? Not really. We'd rather take the shortcut, right? So, the question is lines. How many lines are in the first figure? 4. How many lines are in the second figure? 8. How many lines in the third figure? 12. So what are you guys going to guess on the 20th figure? 80. You see a pattern there, yes? Okay, now, it says to use a table. And homework will specifically say to use a table with a process column, or make a table with a process column. And that's what we're going to set up. And that's what, I mean, this is a very easy problem, yes, but I want to show you how to set the table up, because you know, the workbook page is slightly different than what you would normally do in Math Excel. But I remember on my first quiz, when we have a quiz or test, one of the things you have to do is you have to make a table with a process column. So I want you to have the idea of what I will be looking for. So I'm going to make this table. It's going to have 3 columns. My first column is my input, so to speak. And that is, what are we basing our figurines on? And that is the figure number. So my first column is going to be figure number. My middle column is always the process column. Okay, middle column is always the process column. And my third column is that output column. What are they asking me to find? They're asking me for, not specifically the 20th figure, but how many lines. So that third column is the number of lines. Okay, so let's write down what we know. We already had figure 1, and figure 1 had how many lines? 4. Figure 2 had 8, and figure 3 had 12. So you'll notice I filled in my left column and my right column. Now that middle column is what connects the two. So what is the connection between figure number and number of lines? So, and we've already done this essentially, but how are 1 and 4 connected? In the same way, how are 2 and 8 connected? How are 3 and 12 connected? What are we doing? Multiplying by 4, right? You take figure number, so 1 times 4 is 4. On figure 2, you do what? 2 times 4, which is 8. On figure 3, you do 3 times 4, which is 12. You guys see that orange pen okay? Okay. You guys just have to tell me if something's not working on the screen for you. I can only know if you tell me if something's not working. So now, before we get to the 20th figure, let me throw something in at you. What if, because obviously this pattern keeps going on and on, right? So thinking dot, dot, dot. What if I ask you about the nth figure? How many lines are in the nth figure? How do I figure out how many lines are in the nth figure? What are we doing? Yeah, what did we do every other time? It was 1 times 4, 2 times 4, 3 times 4. So it's n. What do we do? Times 4. And what is n times 4? N times 4 is n times 4, or in other words, 4n. So I know in the Math Excel assignment I usually use it ask this. I honestly can't remember if it does on the workbook or not. But if they ask you how many lines are in the nth figure, what would we say here? We're going to say that there are 4n lines. So I'll even write right here that this was for the nth figure. And I know, that says nth. I don't think you can read it though. Sorry. Nth as in NTH. Just trying to have you guys prepared there. Now, what was the original point of this problem? The 20th figure, right? So what's the idea? Yeah. And at this point, we have a formula, right? It's the number of lines times 4. So we're going to be doing 20 times 4, which is the 80. You guys already said, and it'd be 80 what? 80 lines would answer this question. Okay. Yes, I took a rather easy problem, and I dissected it quite a bit, okay? Bear with me, I'm just trying to get you guys to focus on how to make the tables. So if you're ready, let's look at the next example. How many tiles are in the 25th figure? Use a table. So if you don't mind, can I go ahead and number these? What are we given here? We're giving figures 1, 2, and 3. Let's go ahead and jump and set the table up. Remember I said I want the table to have 3 columns. What's going to be the first column? Just like last time, it's going to be the figure number. Middle column is always process column. Good. And what are they asking me? What's going to be that third column? This time it's how many tiles. Okay, let's write down what we know. We're given figure 1. Figure 1 has what? 4 tiles. We're given figure 2. Figure 2 has 6 tiles. We're given figure 3. Figure 3 has 8 tiles. In the end, we're going to want to know how many are in the 25th. Now, I'm going to tell you also in the meantime, we're going to talk about the nth. Okay, just like last time, I want to talk about the nth. But for the meantime, what I need to know, what's my process? How do I get 1 to become 4? In the same way that I get 2 to become 6 and 3 to become 8, because it has to work. We need the same process to put in that process column that continues to work every time. Thoughts there? Because I don't know about you, but I don't want to draw all the way up to the 25th figure. And for that matter, I don't even really want to make my table go all the way up to the 25th table or 25th figure. Who's putting on? No thoughts here? So what's the pattern you see? It's not going to be my process column, but what's the pattern you guys see? We're adding 2 each time? So if we wanted to keep counting up until we got to the 25th time, we could just keep adding 2, right? 4, 6, 8, so on and so forth. Now, that adding 2 is important because that adding 2, if I recall correctly, that's what you're going to want to multiply your n by. So think about it. If I'm going to say that's what you're going to multiply your n by, so I'm saying we're going to do 2 times 1, 2 times 2, 2 times 3. Is that going to give me the exact right numbers I need? No. How far off am I? Because I'm the same number off every time. I'm off by 2. Which, how someone mentioned it in third hour, this is a good way to think about. If you think back, we have figures 1, 2, and 3, right? If we were to backtrack 1, how many tiles would figure 0 have? 2. That's the number we're going to add every time. So try this with me. It's, because it was going up 2 here, we're going to multiply the figure number by 2. 2 times 1 is 2, And then what do we have to add to get to 4? You add 2 more. Does that give me 4? Yeah. Okay, try it this time, except in the parentheses where I had a 1, this time we're putting a 2. 2 times 2 plus 2. Does that work? Yeah. Try it with the 3. 2 times 3 plus 2. Does that work? It does. So, what's my process for the nth figure? Okay, so 2 times n plus 2. And again, the multiplying 2 is because my number of tiles pattern up here is going up by 2. The plus 2 is if I go back to the 0th figure, it would have had 2 with it. So here for the nth figure, I'm going to say 2n plus 2. That would be nth. Did you guys get 25? What's 25? 52? Because it's 2 times 25 plus 2. So 52 tiles. I think this one is more helpful. Yeah, I think you can hopefully see why the process column is a little more helpful if you can figure out that connection. And I'm hopeful I gave you some pieces to help you figure out that connection. Okay. You've heard me throw around the words input and output, right? Input being whatever you start with. So, for instance, in this case, the figure number was your input. And output being whatever you get out of that, right? Once we use that process column, whatever we get out of it. So our 52 tiles over here was an example of output. I know the Math Excel assignment always used, had some examples using input and output. So I want those words to be familiar with you. The workbook page, I saw some input and output on there. So I want those words, again, to be familiar with you if they don't give you other things you're used to. Okay. Let's look at the bottom example. I don't know if you can see them or not, but in case you can't, I just made those dots a little more bold, in case you're questioning where the dots are on your paper. The graph shows the cost of a certain fish at a pet store. And then there's 3 questions. How much do 6 fish cost, 10 fish, 20 fish cost? Well, again, this is me taking an easy problem, and we're just going to practice the whole process column table, so you can make sure you know how to do that by now. And then we'll talk about input versus output. So, 3 columns. What's my first column? What's the given, or the input, in other words? It's no longer figure number. What's the input that you would be given? What was it? Number of fish, right? If you look down here, number of fish is what's on the bottom of the graph, and that's what they're asking. So my input, or my first column, is number of fish. What's in the middle? Process column, always. And what's on the right? Okay, yeah. The amount of money the fish costs. So, cost of fish, total cost. Something about cost there, right? Okay, it's a graph this time, but it's an easy to read graph. What's that first dot represent? 1 fish cost $2. What's the second dot represent? 2 fish cost $4, and the third dot? 3 3 fish cost $6. And again, I know this is more like the first problem, isn't it? What's the process here? Yeah, you're multiplying by 2 always, aren't you? You're taking the number of fish and multiplying by 2. In the top row, 1 times 2 is 2. Then it's 2 times 2 is 4. And then 3 times 2. So, I'm going to do it to you. N. What's the cost of N fish? N times 2, or in other words, 2N. So, the questions that you guys probably answered way before I got to this point, which is fine. How much do 6 fish cost? 12. 6 times 2 equals 12. How much do 10 fish cost? 20, because 10 times 2 equals 20. And how much do 20 fish cost? 40, because 20 times 2 is 40. One last thing. If I speak in words of input and output, what did we just do? We took the input, we multiplied by 2, and that equals the output. So I'm just going to write that down here. And again, try and get you familiar with those words. The input times 2 equals the output. Okay. That's your lesson. Your homework that goes along with that is practice 1.1 workbook page. Remember, it is the front and back, and for today it is all 20 problems. While the rest of the week I'm not necessarily doing all problems, than just 20, but you are doing all 20 front and back. Bring that back tomorrow, and we will do some kind of check with it at the beginning of the class before we go on to the next lesson. Okay? I'll have some kind of answer key or something for you to check with. As for the workbook pages, I'll leave it up to you. If you want to leave the workbook page in the workbook, you can. If you would rather rip it out, you can. It's up to you. So, I'm not necessarily going to collect as a more, I may just do more of an in-class check. I'm not sure yet. But, okay?